I chose to research how change in environmental temperature can affect muscular performance. So first of all, there's some background that's important to know. This study is very important because 50% of injuries in athletes are related to muscles. Without a warm-up, your deep muscle tissue stays at a constant temperature. However, muscles closer to the surface can reach as low as 20 degrees Celsius in colder temperatures. Before we reach a conclusion about how temperature affects the muscular performance, you need to know a little bit about Charles' law. The basis of this gas law is that in an increase in temperature, the volume increases as well. The relationship between temperature and volume is directly proportional, as seen through this graph. In a simple example of Charles' law, where the number of particles and the pressure is kept constant, you can see that these smaller arrows imply there's a moderate temperature, and as they increase, the temperature is increasing as well, because it's the kinetic energy of the particles. And as the temperature increases and the speed of the particles, that results in more collisions at a higher force than there were before. And so these more collisions are pushing on the outer walls of this container, of any container, and forcing it to expand. Charles' law is nicely exemplified when exercising. So exercising is basically when chemical energy in your muscles is turned into mechanical energy. However, this process is only 20 or 25% efficient. This excess energy is expressed as a loss of heat. And as we learned before, loss of heat, or the heat being given in these blood vessels, so the increase in temperature, causes an increase in volume as well. And this is shown by the blood vessel expanding. The blood vessel expanding causes an increased blood flow, which allows the muscle to perform better. Studies have been made to corroborate this theory. So the first one, conducted by Noonan et al., he stretched muscles that were at 25 degrees Celsius and 40 degrees Celsius until they tore. And he concluded that the average stiffness of colder muscles is greater than the average stiffness of warmer muscles. And if you have a higher stiffness, there's more probability for a tear. Another study was conducted by Scott et al., and he dropped constant masses at heights from 20 millimeters and on by 10 meters until those muscles tore. Here's a graph of that experiment, and the independent variable was the possible temperature in living beings that was changed for each muscle. This is in degrees Celsius, and this is important because these are in vivo temperatures, which are possible temperatures for living beings. And this is compared to the energy used for the muscle to tear, which increases as the temperature increases as well, which means there's less likely for a tear as the temperature increases. This is why one must warm up before high intensity activity. Thank you.